that we went through. This is your family tree of quadrilaterals. So everything a parallelogram has, these rules also go to a rhombus. Everything a rhombus has and a parallelogram also goes to a square. Same thing over here. A rectangle doesn't just have two things, it has everything a parallelogram has. So these, it's kind of like arrows. It leads to the next thing. Everything that's included previously also goes with it. So for their number one, you're talking about different shapes. So the first thing is that we're talking about an isosceles trapezoid. We need to determine, are the diagonals congruent for an isosceles trapezoid? Do consecutive angles, are they supplementary? Do the diagonals bisect each other? So looking at an isosceles trapezoid specifically, everything a trapezoid has also goes to an isosceles trapezoid. So you're looking at these two boxes because they are connected. So we're going to look at the first thing. The first thing wants to know, are the diagonals congruent? So I'm looking, your diagonals are congruent. The next thing I want to know is, are consecutive angles supplementary? So consecutive angles are supplementary for your trapezoid. So both of these go, whatever is in here goes in here. So consecutive angles are supplementary because same side angles add to make 180. Diagonals bisect each other. So whenever you look at your diagonals, these do not bisect. So this piece is shorter than this piece, meaning it's not cutting the diagonal in half. Yes, they're congruent to each other, but they do not bisect. The next shape I'm looking at is just a parallelogram. So if I look at my little diagram paper for my parallelogram, I need to know, are my diagonals congruent? My diagonals are not congruent because one is longer than the other. So this one's longer. I need to know consecutive angles are supplementary. Consecutive angles are supplementary. That's true. The diagonals bisect each other. So when you're looking at your diagonals here and here, they do bisect. So if I put a number here like 6, 6 can go here, 4 and 4, they're cutting each other in half. So a parallelogram, that is true. The last shape I'm looking at is a rhombus. A rhombus is the second shape in my family. So everything a parallelogram has, automatically a rhombus will also have. So parallelogram, I said this, so a rhombus is automatically that. A parallelogram is this, so a rhombus is automatically that. So if I look, the last thing I need to check is if the diagonals are congruent. So my diagonals are not congruent. This piece is going to be longer than this piece. For number 2, this is where we start getting into our math. So for area of parallelogram, you're using area equals base times height. Your base is the entire length of the bottom, which the bottom and the top are the same dimension for a parallelogram. So my base is 30. I need to find my height. So using the Pythagorean theorem, I'm finding my height, which is here. So I'm using a right triangle. I'm using the Pythagorean theorem. I have 7, which is going to be A. I'm trying to find B, which is the height, C, the diagonal. So off to the side, you're doing 7 to the power of 2 plus B to the power of 2 equals 25 to the power of 2. 25 squared is 625. 7 squared is 49. I have to minus 49 to both sides. So I get 576, and then I have to square root it. So I get 24. So 24 represents my height. So I'm plugging 24 into my area formula. So 24 times 30 makes 720. So B. For number 3 is a parallelogram, and I need to find angle H. So if I'm looking at what they gave me consecutive angles, same side angles. Same side angles are going to add to make 180 because one's obtuse and one's acute, so they are different. They are not the same. So I'm doing 7x minus 5 plus 3x plus 15 equals 180. If I combine like terms, 7x and 3x make 10x. -5 and 15 make 10. If I minus 10 to both sides, I get 170. Divide by 10x, x equals 17. I'm not done. I have to find the measure of angle H. So H is over here. So I'm going to plug it in. Either I can plug it into G and subtract from 180 to find its supplement, or I could plug it into F and opposite angles are congruent. So the easier way would just be to find F, and whatever F is, H is automatically going to be the same thing. So 3 times 17 plus 15. So 66 degrees goes here and 66 degrees goes here. Okay, for number 4, still a parallelogram. Parallelograms have opposite congruent sides. I need to find HG, which is here. This base is congruent to the top base. So these are both the same number. So what I'm going to do is I'm going to set those sides equal to each other. I don't even need this. If I wanted to find HE, I could use this to plug it back in. But these I'm just setting equal to each other, and then I'm going to plug it back into this one because I need to find HG. So I'm doing 3y plus 2 equals y plus 18. If I minus 1y to both sides, I get 2y. If I minus 2 to both sides, I get 16. So y equals 8. And then I'm going to plug it back in. So 8 plus 18 is 26. So the bottom would be 26 and the top would be 26. HG is 26. It's a length, that's not a degree, so I don't need the bubble. For number 5, this is mid-segments of trapezoids. So it gives me some numbers. It says R to S is 30. V to X is 44. I need to find TU. There is no X in my problem, so I can literally add a variable. So I'm going to call TU X because that's what I'm trying to find. I can't add an X to a problem where there's already X's, okay? But this one just has numbers. So I can put X there to represent my unknown. So my rule for the mid-segment theorem is that you're taking the top and the bottom, you're adding them and dividing by 2 to equal the mid-segment. It's the same rule as taking the middle and multiplying by 2 and equaling it to the top and bottom added together. So I'm doing 44 times 2 equals the top and the bottom added together. So 44 times 2 is 88. And then I'm solving for X, so I'm going to minus 30 to both sides. Okay, for number 6, it says select all the conditions that prove a quadrilateral is a rectangle. So quadrilaterals is everything on my sheet. I'm looking specifically at my properties for rectangles. So let's look at our rectangle. Everything a parallelogram is goes to my rectangle. It follows it. So everything here also goes here. So I need to choose everything that applies to a rectangle. So it says both pairs of opposite sides are congruent. So I look here, opposite sides are parallel, opposite sides are congruent. Both pair of opposite sides is longer than the other opposite sides. One pair of opposite sides is longer than the other pair of opposite sides. Oh, the light. This says opposite sides are congruent. So we're not going to choose B. C says the diagonals bisect each other. So your diagonals bisect each other. The diagonals are congruent. So for a rectangle, Okay. Where was I? So the diagonals are congruent. So for a parallelogram, the diagonals bisect each other, but when you look at your rectangle, the diagonals are congruent. They crisscross, so they're congruent. And then the diagonals are perpendicular. So this is not true. Your diagonals are not perpendicular. That's whenever you get to rhombuses and squares. And then B is technically true. It says one pair of opposite sides is longer than the other pair of opposite sides because you're talking about a rectangle. Your rectangle's opposite sides, that one's longer than this one. Sorry, I had like two different people knock on my door and now I'm flustered. So for number seven says which reason justifies each statement in the proof below. Select the correct answer for each missing statement for the proof. So we're talking about a parallelogram. So the first part is saying that it's a parallelogram. It's given. I don't have to do anything with that. AB double lines. This means parallel. So AB is parallel to CD. So opposite sides of a parallelogram are parallel or opposite sides of a parallelogram are congruent. We are not talking about a congruency symbol. A congruency symbol is an equal sign with a squiggle. So we're talking about parallel. So opposite sides are parallel. AC is a transversal. Definition of transversal. I don't have to choose anything for that. This is where you need to start marking your picture. So BAE is focusing on A. A is the middle letter. Is congruent to ECD. ECD. So right here. Those are congruent. Because it has the congruency symbol, I need to put it on my picture. So these types of angles, we have to decide if they're vertical, corresponding, or if they're alternate interior angles. These are alternate interior because they jump across the transversal. The next part is looking for a pair of vertical angles. I'm going to mark this on my picture because we have congruency statements. So AEB is congruent to CED. Those are vertical angles because they crisscross over. AED is congruent to BEC. These are also vertical angles. So they're trying to trick us here. So we have B's vertical and B's vertical. So I'm just going to put a little mark next to both of those. The next one says ABE. The next one says ABE and CDE. Those are not vertical angles. Vertical angles jump across an intersection. So we have two choices. So I'm going to mark both of them and then I'm going to come back to that because I need to see if I'm talking about these triangles or if I'm talking about these triangles. So the next thing says AB is congruent to CD. So this is a congruency statement. It says it's equal. So I'm going to mark it. AB is congruent to DC. And then I want to know, are those opposite sides are parallel or opposite sides are congruent, or is it a given statement? We're talking about congruency, so they are congruent. So B is your answer. This is where you're going to pick your triangle statement. We're talking about triangle ABE is congruent to triangle DCDE. So if you read these, ABE is talking about this triangle. And CDE is talking about this triangle. We need to figure out what statement from our triangle congruency theorems represents this. So if I cover up one of the triangles, I'm just looking at the green triangle. I've marked a side congruent and I've marked an angle and an angle. So I need two A's to represent each angle and a side. So out of our options, we need two A's and a side. This one could work. This one cannot work because it has two sides and an A, so that's out. And then two A's and one side. So I need to choose between angle, side, angle, and angle, angle, side. So this means the side is between the angles. This means the side is off to the side. So in this picture, if I look at one of my triangles, I have my side. My side is not between my angles. Angle, side, angle would be all on the same line together. So this is angle, angle, side. So it's got to be C. And then 8, every single time after you justify saying that the triangles are congruent to each other, they're congruent, then it's going to be corresponding parts of congruent triangles are congruent, because then you can just say everything on the triangle is equal to each other because it's a triangle and triangles have congruent sides if they're congruent. So let's go to the next problem. Next problem is number 8. A lot of people have been skipping these on the assignments. So number 8 says use the figure to match the angles with its measure in the rectangle. So I would just move around the angle and then go back and fill it in later. So 50 can go here. Vertical angles are congruent. So vertical angles 50 can go here. Okay. I know next to it is its supplement because they make a straight line. So 50 plus something needs to make 180. So this would have to be 130. 130. So I have 130, 130, 50, 50 because half of it has to make 180 because it's a straight line. 30 plus 50 makes 180. Which makes sense. That's obtuse. This is obtuse. This is acute, and this is acute. Now I got to find all the rest of the angles. So if I know that this is congruent, I have congruent sides. This is 50 degrees. I have to fill out this angle and this angle. So I'm taking 180. I'm minusing 50. I get 130. And then I'm dividing by 2. Which is 65. So each angle here and here is 65 and 65. 65 can also go on the other side because they're congruent triangles. 65, 65. And now I need to find right next to it. This is a right angle. This is 90. So I'm taking 65 and I'm minusing it from 90, which gets 25. So 25 can go here, 25 can go here, 25 can go here, and 25 can go here. So if I look at my questions, it says the measure of angle MJ or MNJ. So if I'm looking at MNJ, where's N? Oh, it's in the middle. M to N to J. Where's J? J is over here. Talking about the middle letter. So I'm focusing on N. N is at 50. So 50 degrees, which is B. The next one says MJN. So where's J? MJN. So now we're talking about, let me use a different color. Now we're talking about this one, M to J to N. So in the middle, we're focusing on J. J is at 65. So this one's 65, which is C. And the last one is going to be MLN, which cuts in, which is this little angle right here, which is 25 degrees, which is A. For number 9, it gives you a graph and some coordinate points. We're going to plot the points first, and then we have to find the mid segment. So if I plot my points, I start with the first one, which is 0, 0. Then I have 0, 6. Wait, 0, 6 is over here, right? 0, no, 0, 6. 1, 2, 3, 4. Then I have 8, 6. 1, 2. And then 14, 0. So if I count the distance of the top, 1, 2, 3, 4, 5, 6, 7, 8. This is 8. The distance at the bottom is 14. I'm taking the top and the bottom. I'm adding them together, and I'm dividing by 2 to find the middle. So 8 plus 14 is 22. 22 divided by 2, right? 8 plus 14, 8. plus 14 is 22 divided by 2 is 11. Okay, 10 is area of a trapezoid. So my area of a formula for a trapezoid is area equals 1/2 base 1 plus base 2, oh crap, times the height. That formula will be given to you tomorrow. You don't have to remember it. So I have to use a Pythagorean theorem to find my height. So I'm going to draw in a line. If I know the top is 150 and the bottom is 300, this piece would need to be 150. So I need to find my height using the Pythagorean theorem. So this is C, this can be A. I'm trying to find B, which represents the height of the shape. So I'm doing 150 to the power of 2 plus B squared equals 200 squared. So 150 to the power of 2 is 22,500. 200 squared is 40,000. I'm minusing 22,500. So I get 1,750 or 17,500. And then I'm square rooting. So my B, or my height, is 132.3 because we're going to round to the nearest tenth. So 132.3 because that's 2.8. So rounds up. So that's my height. Now I'm going to plug it in. So the top base is 150. I'm adding the bottom, which is 300. And I'm multiplying by my height, which is 132.3. So if I add them, 150 plus 300 is 450. I'm multiplying by the height. And then I'm dividing by 2 because I'm cutting it in half. So I get 29,767.5. That's my area. The next one is also a trapezoid. So it says one pair of base angles of an isosceles trapezoid, so I know the base angles are congruent, is 3 times x minus 8. And this one's also 3 times x minus 8 because it's pair. A pair. The other pair is 2x plus 4. So what we're going to do is we're going to take half of it and we're going to add to make 180 because consecutive angles add to make 180. So I'm doing 3 times x minus 8 plus 2x plus 4 equals 180. So if I distribute into my parentheses, I have 3x minus 24 plus 2x plus 4 equals 180. If I combine like terms, I get 5x and minus 20. I'm adding 20 to each side, so 5x equals 200. 200 divided by 5 is 40. So I just need to find x. So 40 is my answer. I thought I was gonna have to plug it back in. For 12, this is another proof, extra practice for your proofs. So now we're talking about a rectangle. It says ABCD is a rectangle. So if I know AE is congruent, I'm marking it on my picture. AE is congruent to CE. The reason why they're congruent, it says the diagonals of a rectangle are equal, which is true. AC does equal BD, but that does not make sense to use that these are congruent to each other. Diagonals of a rectangle bisect. Bisect means cut in half, which means they're equal. So B. AC is a transversal, because definition of a transversal. I'm looking for vertical angles. So ADB is congruent to CBD. Those aren't vertical angles. AED is congruent to BEC. Those are vertical angles. Let's check another one. ABC, that's the whole thing, is congruent to BCD. That's the whole thing. So those aren't vertical angles. So just B. DE, so this is a congruency, so I'm marking it on my picture. DE is congruent to BE. Diagonals of a rectangle are equal. Diagonals of a rectangle bisect. Same thing as before, they bisect, so these pieces are congruent to each other. Yes, the diagonals are congruent to each other, but we're not even talking about the other diagonal. So now I have three pieces. I need to check. It says ADE, so this triangle here is congruent to BCE. I need to figure out which theorem to use. So if I cover up one of my triangles, let's cover up this one over here. If I cover up one of my triangles, it doesn't matter which one you cover. I need to justify how I know they're congruent. I have a side marked, and an angle. Notice the angle is between them. So I have two S's and an angle. So I have angle, side angle. This has two A's and one S, that's out. Two sides and an angle. This one has two angles and a side. Side, angle, side is the theorem to prove that those triangles are congruent. After I've proven that the triangles are congruent, I can say anything on the triangle is congruent. So AD is congruent to EC because once I know that they're congruent, everything else is congruent. So corresponding parts of congruent triangles are congruent. The last one is another practice of a midsegment of a trapezoid. So it's just like number 9. Oh, it's number 9 twice, but the other problem. So we're going to plot our points. So 0, 0, 0, 12, 6, 12, 16, 0, so I count the distance of the top. 1, 2, 3, 4, 5, 6. So this distance is 6. The bottom distance is 16. I'm adding them together, 6 plus 16, and I'm dividing by 2. 6 plus 16 is 22. Ironically, this is the same as the other problem. I divide by 2, which makes 11. And I'll zoom out so you can see all the answers really quick. So there's the back. And then there's your front.